All right, I like this video because there's very, very little new in this video. All right, it's just do it again. So let's look at this. The derivative with respect to x of f of x, we denote that by f prime of x. We just add a prime. So what if we go to the next level? All right, what if we have d dx of f prime of x? Well, this is what's called the second derivative, and we just add another one. All right, so that's the second derivative. You just take the derivative again. And there's a third derivative and a fourth derivative. Fun fact, by the way, the third derivative, we'll write f triple prime of x, but after that, we don't keep adding primes. We actually use a number in parentheses. So if I wanted to ask you what is the 51st derivative of x, you'd write f to the 51st, like that. But don't worry, there will be no 51st derivatives in this class. The second derivative is what's important, so don't worry about that. All right, but just, you know, a little fun math fact for free. You don't even have to pay for that. Well, outside of the fact that you paid for the class. I'm getting really off topic here. Let's do example 3. Speaking of third derivatives, find the second derivative of f, or f double prime of x, or f of x is equal to x cubed plus 1 over x. So to find the second derivative, you just take the derivative of f prime. But of course, we don't have f prime yet, so let's start by finding f prime. F prime of x is going to be, let's use the power rule here. 3 comes down. Exponent gets subtracted by 1. Remember, by the way, 1 over x, that's x to the negative first power. So we'll use the power rule with negative 1 as the exponent. Correct? 1, and our new exponent's negative 2. And let's keep it in that form because we're going to take the derivative again. All right, so f double prime of x, ooh, it's sliding off the screen, is equal to the derivative of this. So again, the power rule gives us 6x, and then bring down the negative 2. Negative 2 times negative 1 is positive 2, and subtract an exponent. And that's all there is to it. You just get to take the derivative twice. It's kind of hard to, I kind of cut off my negative 3 up there. There we go. So that's the second derivative. Now there is another notation for the second derivative. Again, we're just introducing a lot of new notation today. So f double prime of x, we also write that as d squared y dx squared. So it looks kind of weird. The 2's are kind of in weird spots. And there's a reason for that. It's basically because this is like our second differential operator. And we're too lazy to write parentheses, but there should be parentheses here. Sort of. There's a lot of comments to make here that aren't really important for this class. But this is another way that you can see the second derivative. All right. So that's going to lead us to example 4, where I want you to look at this function, y equals x to the 4th minus 5x cubed plus 7. And let's combine something from video 2 and video 3 and video 1 because we haven't done video 3 yet. So forget I said the word 3. All right, I want you to find the second derivative of y with respect to x evaluated at x equals 3. So that vertical bar, that worked for second derivatives too. Perfect. So first we have to find the first derivative, then we have to find the second derivative, and then we have to plug in the number. So what do we got? Y prime is going to equal, let's use the power rule, 4x cubed. Let's use the power rule again, 15x squared, and then the derivative of a constant is 0. So if you want to add a plus 0, you can, or if you don't, that's fine too. We're going to be using the power rule a lot. I promise there's other rules. There's other ways to take derivatives, but we just don't talk about them for a while. So power rule again for the second derivative is going to give us 12x squared minus 30x. And now we have to plug in x equals 3. And I know it said find d squared y dx. That is the same as y double prime. I like writing y double prime because it's less writing. But I am okay with either notation. They're all a-okay. So let's find y double prime evaluated when x is equal to 3. So again, you can use that evaluation bar like this as well. All right, so we're going to get 12 times 3 squared minus 30 times 3. And you type that into a calculator, you'll get the final answer, which should be, I have no idea, 9. This is 108. 108 minus 90 should be 18. And there you are. So, video 2. Video 3 is going to be a little longer. We've got some applications for you. Everyone loves some applications. This is business calculus after all. So stay tuned. But go ahead and work on these problems first. Remember, it's always best to watch a single video, do those problems, and then move on to the next one. Easier to learn. And honestly, it's just less boring than listening to me talk for that long at once.